So there's one particular item I think all homeowners should at least be aware of so they know what to look out for. And especially as we get into these warmer months, as the AC unit is going to be running more, the most common issue I see that comes up with AC units, and therefore is also the biggest scam that I see being committed by some of the HVAC companies that are out there, come down to your capacitor. And I've seen where some people have been charged up to $2,000 to replace this $10 to $20 part. So in this video, I'm going to show you how I go about testing and replacing these, and some things to look out for in the event that this happens to you. A lot of times you can catch these going bad before they actually are bad. So let's go ahead and jump right in. All right, so here is the AC unit, but the first thing that should always be done before doing anything electrically, which definitely includes anything AC related, is always want to locate your disconnect. This might be a pull-out disconnect like I've got right here, as you can see. If you don't have a pull-out disconnect like this, then there should definitely be a breaker somewhere that goes to your AC unit. And now my power is disconnected to my AC unit. I can either flip it upside down, put it back in, or I always like to just put it on top so I know it's disconnected. But to be extra safe, it's almost always best to also turn off the circuit breaker that's going to your AC unit. All right, so now that the power is off, now I'm going to take the cover off to my AC unit. I've got 4 screws around the cover of this. The screw size of most of the screws on these AC units is 5/16. You can very easily get either a 5/16 nut driver, or they make what they call AC screwdrivers or nut drivers that already have your most common sizes that are needed for AC units. So 5/16 is a big one, a quarter is a big one, and there are some other ones. And like always, I'll have links to this along with all of the other tools, all of the capacitors, different ranges and sizes and brands and types. I'll have links for everything you see in this video down in the description down below. When you click on those links, it'll take you directly to whatever you clicked on that you saw in this video, so you can check it all out for yourself. All right, so here are the main components of most AC units. Down here at the bottom, you're going to see this down here. This is called the contactor. This is where the power is coming in and then being distributed to all the rest of the parts of the unit. Over here, this is the one we're after. This is the capacitor. And of course, we've got a circuit board up at the top and a bunch of wiring. But before I do anything with this, even though I have pulled the disconnect, or if you have a circuit breaker, the circuit breaker's been turned off, I want to verify that there is 100% without a doubt no electricity flowing into this AC unit. So what I'm going to do is I'm going to take my multimeter here. I'm just going to turn my multimeter on to where it shows this V, which is for voltage and alternating current. And now I want to check down here at the contactor where my lines are coming in here at the bottom. This is where the power would be fed from, down here at the bottom coming from the house. Now I want to check each side of my contactor. So I'm going to start over here on the left side of my contactor and then go down with my other probe down here to the ground. And as you can see, we've got 0 volts there. I'll leave the one probe on the ground down there. I'll move my other probe on the contactor over to the screw on the right side of the contactor. And as you can see, I'm still getting 0 volts. So this is in fact turned off. There is no power flowing to it. So at this point, I feel comfortable to where I can start working on it. All right, so now that we've verified that the power is in fact off, before I start working on this capacitor and start touching things, these capacitors can possibly still hold a charge, and one that can pack a pretty good punch. Again, these basically are storing energy. However, once the unit is off and disconnected, this capacitor should have already discharged naturally through the windings. But sometimes they do still hold a little bit of a charge. So before anybody starts working on this, the best thing to do is always make sure that these are actually discharged first. And what most HVAC techs will do in order to do that is they will take whatever nut driver or screwdriver that they're using. They will hold on to the insulated end. They will take the metal end of it and they will go from one terminal to the next, where this one over here, this is the common terminal. This is the HERM, and the one in the back is the fan. So what I like to do is I like to first touch to the common, then over to my HERM or hermetic terminal. Then I'll go from common to the fan side, and I will just go back and forth a few times just to make sure that this is in fact discharged, so I don't receive any kind of a shock. The next thing I always recommend doing before you start touching these terminals and removing wires is make yourself familiar with where each of the wires go, because if you have to replace it, the wires are going to go on the same terminals that they are currently on the old one. So what I always recommend people doing is you can look at the top of the capacitor, and most of the time there's going to be some sort of labeling where this says C, which is for common. You'll see HERM for the HERM, and then most of the time you'll also see fan for the fan terminal. So what I always recommend people do, and I do it myself just out of habit and to make sure that everything gets put back where it's supposed to, is I always recommend going in and taking pictures all the way around of where each one of those wires are placed before I start disconnecting them. So by taking those pictures, it really can help with making sure that everything gets put back the way that it was and the way that it needs to be in order for the unit to work properly. Now it's time to test this thing. One really big mistake that a lot of people make when they do this. And I will also say this is a way that some of the AC companies out there will try to fool people that their capacitor is bad. And that is in trying to take your reading of this capacitor while all of these wires are still connected. The wires on these terminals have got to be removed before doing any testing. You will not get a proper reading. You will not know what your capacitor is actually reading at until that is done. So something to look out for if somebody's doing it for you, and of course something that I always want to do before I actually take my reading. So I've already got my pictures, so I'm going to go ahead, start removing my wires from each one of the terminals, and so now I'm ready to take my readings. Now I will just tell you that this capacitor, I don't expect it to be bad because it's been running perfectly fine, but I'm going to find out with you what condition this is actually in. And this is something I actually like to do on at least a yearly, if not semi-annual basis, just to make sure that I'm staying ahead of things and try to catch it as it's going bad before it actually does go totally bad and my AC unit just doesn't work at all. All right, so I'm going to take my multimeter again. I'm going to hang it up here at the top. Now this time I'm going to turn my multimeter on, but I'm going to put it over here to where it's actually got a resistance and continuity symbol. That's also the setting where we're going to find the microfarads for this particular clamp meter. All right, so now that I've got that all set up, now I'm ready to take my readings. One thing to pay really close attention to is, in order to know what your readings should be, there's usually going to be a label on your capacitor which is going to show you what they should be. So on this particular one down here at the bottom, it says 70 and 5 microfarads. The 70 is what we should get as a reading, or over here within 6% plus or minus. So we should get within 6% of 70 microfarads going from the common to the hermetic terminal. The 5 is for the common to the fan terminal. Again, we should get within 6% plus or minus. All your capacitors are different. They're all going to say different readings on them. If you do need to replace them, make sure you're replacing them with the same size and same type. You also want to make sure on this one it says 370 or 440 volts AC. So if you are replacing them, verify the numbers, make sure you're getting one that is exactly the same. All right, so my first reading, I'm going to go from the common to the herm or hermetic terminal. And again, we should be within 6% plus or minus of 70 microfarads. So I'm going to take my first probe, I'm going to put it over here on my common terminal, like so. Take my second probe, I'm going to put it over here on the herm terminal and see what reading we get. All right, so we're showing 69.1 or 69 microfarads. That is well within the 6% of that 70 microfarads that we need to have. At 70 microfarads, to get within 6% plus or minus, that would be about 4 microfarads low or high. We're only 1 below the 70. So from the common to the herm side, that part of the capacitor is showing that it is still in good condition. So now I'm going to check the fan reading. So I'm going to keep that one probe on my common, take my second probe off of the herm and move it over here to the fan and see what our reading is then. And as you can see, it's showing 4.997. So pretty much right at 5, which is what we want to see. So this capacitor is still in very good and working condition. But now I'm just going to really quickly show you up close what it would look like if you were testing a bad capacitor and what type of readings you might get. All right, so while the capacitor that's out in my AC unit is still good, which is a good thing, I want to really quickly demonstrate for you exactly what it looks like when you test a bad capacitor, what kind of readings you might expect if your capacitor is actually bad, and just how clear it really is. All right, so the first thing I want to do is get my multimeter set up again. Again, all I'm going to do is set it over here to this setting, which has continuity, it has resistance. Just going to change the settings to where we can read microfarads. All right, so first one I'm going to check is I'm going to connect my first probe or alligator clip down here to my common terminal. Then I'll take my second probe or clip and I'm going to connect it to my fan terminal up here. And again, we should be within around 6% plus or minus of 5 microfarads. And as you can see, we're getting 7.19, 7.2, and that is going to be well above the 6% allowance above that 5 microfarads. For instance, 6% high of that 5 microfarads would be around 5.3 microfarads. We're showing 7.18 now, or 7.19, and that is way out of range for our reading going from the common to the fan terminal. So we know that side is bad, but now let's check from the common, and then we're going to take this other probe that was on the fan, I'm going to put it on the hermetic terminal, and we're going to see what that reading is. All right, so as you can see, the multimeter is just jumping around. This is usually a really good indication that the capacitor is bad, but just to make sure it's not where I have my clip, I'm going to put it on one of the other terminals, see if we get a different reading, because that can sometimes be the case due to corrosion. All right, so as you can see, I'm on the third terminal for the hermetic side, and it's still just jumping around like so. I'm just going to really quickly, just to see, I'm going to take my alligator clip off, and I'm just going to take my probe then and just put it into a nice clean spot where I know that there's no surface rust or anything like that. And as you can see, no matter what I do, it just continues to just jump around. Eventually this is going to settle on, it's going to show OL, which in a lot of multimeters means that it's over limit, which means in most cases that we don't have a good connection. But at the end of the day, definitely means that this capacitor is bad. So it was bad going from the common to the fan, and it was definitely bad going from the common to the Herm. All right, so now that I've shown you all of that up close, if I had found that this was a bad capacitor, that's when we now need to replace it. These are almost always being held in by these straps like this. They are mounted to the unit right back there. You see those two screws, top and bottom. So all we would need to do in order to replace this is remove those two screws. Those particular screws are 1/4 inch. Because they're kind of in there, kind of deep, I like to use an extension on an impact, have my 1/4 inch nut driver on it, and then I just remove those screws. And then the capacitor will come out just like that. All right, so now at this point, with it being removed, it's just as easy as pulling those two pieces of metal apart. The capacitor will pull out just like that. That's when that would get set aside. You would get your new capacitor. Again, want to make sure that the labels match the old one to make sure you got the proper capacitor for your size unit. Then just do it in reverse order. Then it gets put down into those straps and it will just slide down into place. I always personally do, and also recommend making sure that the label of the new one is also facing out, so that for later reference for yourself or whoever's working on it, they can easily see what the capacitor is and what it should be reading. So then it just gets placed back in the unit like so. Then you just tighten down the screws. All right, now that that's strapped into place, now it's time to reconnect the wires. So I want to refer back to the pictures. Just make sure that all the wires are going back into the proper places, because if someone does not get this connected properly, at the very least, it's not going to work. And at the very worst, it may actually cause some damage to some of the parts. And not only do we want to make sure that all the wires are going in the proper place, we want to make sure that we don't miss any wires. So if there were 5 wires removed, there need to be 5 wires replaced onto the new capacitor. And then once I've made sure and verified that, it is at this point the capacitor is now installed, it is all wired up, and the unit is ready to be tested and run again. But before I do anything with that, I want to make sure that the panel is replaced back on the top of this unit. So it just slides back up into place, the opposite of the way that we removed it. And then I just need to go ahead and replace all the screws that I removed from the panel. All right, so now that everything is hooked up, the panel is back on. Now I can turn the power back on and test everything and make sure this unit is back up and running. So I'll just take my disconnect, reinsert it the way that I pulled it out into the disconnect, and then close it up. And now at this point, now that everything is reconnected, I can turn my thermostat on, set it to a setting that's going to make the unit turn on so that I can watch it turn on, make sure that it's running properly, and then I'll also want to go inside and check the vents inside the house to make sure that cold air is coming out of those vents. Once I've verified all these things, I know that my unit is back up and running properly, and by doing it myself and having some tools I'm going to use for other projects anyways, it's only going to cost me from this point going forward the cost of the capacitors, which again are going to be anywhere from $10 to $20. Of course, you can also get some of those premium capacitors, which can last a little bit longer. Those are going to range anywhere from around $35 all the way up to around $80. But aside from that cost, it is not abnormal to be charged anywhere from $400 on up to, again, I've heard of people telling me that they've been charged $2,000 in order to replace a $10 to $20 part. And this job, if I'm not filming it, it really only takes me around 5 to 10 minutes in order to do. Now, one thing I just want to really quickly note is while this is probably one of the most common things that's going to go wrong with your AC unit and one of the biggest scams that I see being done, there's actually a whole list of other items that can go wrong fairly commonly with an AC unit, things that can be checked and things that can be easily replaced if you feel like you have the knowledge and capability of doing so. If that would be of interest to you, then all you have to do is click on one of these 2 videos right over here. As soon as you click on it, it will take you directly to that video. But I hope that you found value in this video, and if you did, if you could do me a huge favor, hit that thumbs up button right down below. And of course, if you have any questions or comments still, you can leave those down in the comment section. And I'll catch you all in the next one. See ya.